Welcome back to Past Quest, where we explore the fascinating stories of our universe. Today, we'll unravel the complex process that led to the formation of our very own solar system. How did a cloud of gas and dust transform into the sun, planets, and moons we know today? Let's dive into the cosmic journey of our solar system's birth. The story begins around 4.6 billion years ago, long before Earth existed. Our solar system was born from the remnants of older stars that had lived and died in our galaxy. In the vastness of space, a giant cloud of gas and dust, known as an asterisk solar nebula, was floating in silence. But this nebula wasn't calm for long. A nearby event, possibly a supernova explosion, triggered a shock wave that disturbed the cloud. This shock wave caused the nebula to collapse under its own gravity. As it collapsed, it began to spin faster, creating a flattened, rotating disk of material. This disk was the birthplace of everything we know in the solar system today. At the center of this spinning disk, most of the material clumped together, driven by gravity and heated up. Over millions of years, this central mass became hotter and denser, eventually reaching the temperatures needed for nuclear fusion. At this moment, our sun was born. The sun, now a fully formed star, dominated the center of the system, its gravitational pull shaping the fate of the remaining gas and dust swirling around it. But the story doesn't end there. The leftover material in the disk didn't just disappear, it began to come together, forming the building blocks of planets. Around the sun, small grains of dust collided and stuck together, forming larger and larger clumps. These clumps eventually grew into objects called asterisk planetesimals asterisk. These were the first solid bodies in the solar system, ranging in size from a few meters to hundreds of kilometers. The process of planet formation was far from peaceful. The early solar system was a chaotic place filled with collisions. Some planetesimals grew larger, while others were shattered in violent impacts. Over millions of years, the largest planetesimals accumulated more material, eventually becoming protoplanets, the seeds of the planets we see today. As the sun ignited, it unleashed powerful solar winds that blew away much of the remaining gas in the inner solar system. This is why the planets closest to the sun, Mercury, Venus, Earth, and Mars, are rocky. These planets, known as the asterisk terrestrial planets asterisk, formed mostly from heavier elements like iron and silicon. In contrast, farther out in the solar system, beyond the frost line, it was cold enough for lighter elements like hydrogen and helium to remain. This allowed the outer planets, Jupiter, Saturn, Uranus, and Neptune, to grow into gas giants. These massive planets accumulated huge amounts of gas, creating thick atmospheres around solid cores. While the planets were taking shape, many smaller objects were also forming. Some of these objects would become moons, while others would remain as asteroids and comets. For example, Earth's moon is believed to have formed from a giant impact between Earth and a Mars-sized body. This collision sent debris into orbit around the young Earth, which eventually coalesced to form the moon. Similarly, the moons of Jupiter and Saturn likely formed from the disks of gas and dust surrounding these massive planets. Meanwhile, in the asteroid belt between Mars and Jupiter, leftover planetesimals that never formed into planets became the asteroids we see today. These small rocky bodies are remnants of the early solar system, offering us a glimpse into the conditions during its formation. About 4 billion years ago, the solar system went through a period known as the asterisk late heavy bombardment asterisk. During this time, the planets experienced a surge in asteroid impacts. It's believed that gravitational interactions between Jupiter and Saturn sent a wave of comets and asteroids into the inner solar system, bombarding the planets and their moons. This period was crucial for shaping the surfaces of many planets and moons. For example, the craters on the moon are evidence of this chaotic time. It's also possible that water and other key ingredients for life were delivered to Earth during this period via asteroid impacts. After the late heavy bombardment, the solar system began to calm down. The planets settled into more stable orbits, and the chaotic collisions became less frequent. The solar system entered a period of relative stability, which has lasted for billions of years. But even today, the solar system is still evolving. Moons continue to orbit their planets, asteroids still fly through space, and occasionally, comets visit from the outer reaches of the solar system. The story of our solar system is ongoing, with new discoveries waiting to be made. And so, from a swirling cloud of gas and dust, the sun and its planets came into being. Our solar system, with its diversity of planets, moons, and small bodies, is a testament to the power of gravity, collisions, and cosmic forces. From the rocky worlds near the sun to the gas giants in the outer reaches, each part of the solar system has its own unique story. If you enjoyed this journey through the early days of our solar system, don't forget to like the video and subscribe to Past Quest. There's so much more to explore, so keep wondering and keep exploring. Like and subscribe for more fascinating cosmic content. Comment below with what part of the solar system you'd like to explore next. Share this video with friends who love space.